Okay, let's go back to our Unity, and now we have an interface and we have a state machine. Now what we need is our script for our cube boy. Now this is cube boy. Say hello and let's start coding our cube boy. Okay, so what let's attach cube boy to this, our cube boy, and double click, and we need our cube boy to move to whatever point we want it to move. Okay, so we could have a transform way, but I want to quickly do the nav mesh way, so let me quickly add a nav agent on our cube, and on our plane make it navigation static, add, oh sorry, go into navigation window and bake. Okay, I just don't want to code in a whole movement logic for now because it's beyond the scope of this video, so we'll just tell our nav mesh agent to go someplace and it will go there. Okay, so back to our cube boy script. In the cube boy, first of all we need it to have a state machine. For obvious purposes, let's quickly make a field that can contain our state machine, and let's call it my state machine, or let's simply say state machine with a small s, and which is equal to new state machine. That's it. It just created a new instance of our state machine script or class for itself. So basically, if we had 10 cube boys, each one would have an instance of its own machine. Okay, so this is the state machine's class script. Basically defines how this machine works, but it can have as many instances as it wants. Okay, so cube boy. Now our cube boy has a state machine. Now if we remember this our owner, which is cube boy in our case, needs to tell the machine which cartridge to run. So we need cartridges. So we haven't coded any cartridges yet, so let's make one. Let's go create C# script, and this state is search for food. Let's say we want to search for food. Okay, so this is our state, which is search for food. It's a cartridge which makes our machine search for food. Okay, so if I hope you can already imagine how reusable the system is. Once we have made a plan or defined how to search for food, no matter how many games we make in the future, and basically we could do that. So instead of search for food, it would be way better if we made a cartridge which simply allows us to search for things. Imagine how much more reusable that is. Search for. So that's all this cartridge does. It makes us search for something, but what is that thing we're searching for will be provided by whoever is providing the cartridge. Okay, fun, right? So this is our search for cartridge, and we call it ice. We implement ice. My IntelliSense has gone bonkers. Let me quickly run it. Excuse me. Okay, now we are making a state which will allow anyone using that cartridge to search for something in the map or in the level or wherever. So it's going to require certain things. First of all, it's going to require my Visual Studio to load up, and then it's going to come on, state. Okay, I have pressed enter. It's just okay. So now iState wants to implement its functionality, because iState has certain things it says that it should have. Okay, so search for, let's quickly implement the functionality. Enter, execute, exit. We need to have all these three methods for the iState implementation to work. I just used a shortcut from ReSharper plugin, but you can do it manually as well. Okay, so enter, execute, exit, and the search for cartridge is not quite because it's happy. Whatever the iState interface wanted, we have that. Now, in the enter phase, whenever this cartridge is plugged in, I don't think we need anything. However, we need two things for this search method to work. For example, first of all, we need to know which layer are we looking in. Of course, whenever we're going to do a search, we're probably going to do a ray cast or an overlap sphere or sphere cast. Whatever we're going to do, we need to know which layer we are looking for our target objects in. Okay, so we say layer mask search layer. Okay, so whatever layer we are looking in. Okay, so we have a layer mask, but whenever this cartridge is produced by whoever wants to use it, needs to tell this cartridge which layer it's looking in. So we need a constructor. Okay, so in the constructor we need to ask for which layer you want me to look in. So there's a shortcut. I think this one works without visuals to ReSharper, but there we go. So in the constructor we asked for which layer you want me to look into it, and then we saved it inside our field, private field. And in case you don't know what a constructor is, basically when we do this new float, or let's say vector3 or vector2, that's the constructor being called. So in these brackets, whatever we are providing, for example in the case of vector3 we usually provide xyz, so basically this is this requirement. Okay, so when we say var cartridge is equal to new search for, see, it's asking for a layer mask. So when basically this is a way of saying that whenever this cartridge is produced, it will ask for this information, or else it won't be produced. It's a required information. Okay, so now we're happy. In the execute method, we want to look for whatever is in that layer and do something. Okay, so let's, for this purpose, we say this script only does finds an object in that layer and then tells us where it is. Or let's just say for this example, it just goes there. Okay, so basically, although the name suggests that it only searches for our example, in order to show you how to move things in states, etc., what we're going to do is search for as well as move to that location wherever we found that object. Okay, so what we're going to do is, first of all, we're going to say let's do a overlap sphere. If you don't know why I don't use physics dot sphere cast here instead of overlap sphere, is because this is our cuboid, this is our food, and if we did sphere cast, no matter how big it is, if when the sphere cast actually starts, any objects which are inside that sphere already are not detected. So we'll shoot no matter how big of a sphere. If this food item is already in that sphere, it won't be detected. So what we will do is do an overlap sphere and say, okay, tell me which objects are inside this sphere. That would be the correct functionality we need in this case, because we want to find certain objects in a radius. Okay, so we will do this. First of all, we'll create a variable. In fact, var, let's say hit objects, okay, is equal to physics dot overlap sphere. Okay, so overlap sphere is asking for position. So the position is obviously where we are right now, but this is a cartridge and it does not know where it is right now because whoever created it did not tell it that, and it obviously is not a mono behavior, so it's not a component, it doesn't know where its transform is or things like that. So that information we also need to provide. Okay, so what we can do is, although there is interesting conundrum here, if we provided the cartridge the position when it was created, for example, our cube boy is here and he says, okay, search for food, and provided the location where it is right now to the cartridge. What if the cube moves here? For example, the cube moves here after the cartridge was created in search for the food, for example, and the sphere or the search algorithm or the search command would still be happening here. We don't want that. We want the current location of the cube boy or our object to be used in this cartridge or search for system. So what we need is, basically, we need a reference to the cube boy. We need the cartridge to know where its daddy or cube boy or whoever created it is. Okay, so what we can do is search layer, and we can also provide it with game object owner. Okay, so whoever created the cartridge can also be provided. Okay, so we can also quickly create a script called here game object owner game object, and let's not do it this way, let's do it with the shortcut initialize from constructor, and now we have an owner game object provided to us. So in the overlap sphere we say wherever the creator of this object is currently located, that's where I want to search from. Then float radius. Okay, so we also need to be able to provide different values for our search radius, because cube boy could be able to search within 50 meters, and another one who wanted to use the same cartridge could, due to some gameplay reasons, should only be able to search within 20 meters. So it's always better to take this kind of information, and let's say search radius. Okay, so comma use, and why did I, never mind, let's do it this way, float search radius and initialize it from here. Okay, so now we have been provided a search radius as well, and this one is giving me a warning. No, I don't want to do that right now. Okay, now comma, now we can provide it with the search radius as well. Okay, so now we have array of colliders which has been provided by physics.overlap sphere, and now we want to loop around that. It's saying, yep, it's correct. Okay, now we want to loop around that array and see if we touched or if we have food within our range. Okay, so let's quickly do hit objects dot length and just loop around that, and for each object let's say if hit object. You could also do a for each, but let's, for performance constraints, let's do it. Okay, hit objects, if hit object and the currently being considered object I dot compare tag, let's say food. Okay, so inside that searchable layer there could be other things as well, so we are currently looking for food. Okay, so this is a bad way to do this. Why? Because we should provide this. Okay, why? Because the search for has been told which layer to look in, but it's automatically looking for food. That doesn't make sense. The cartridge should provide this functionality to be customizable. So we do this. We say string tag to look for, and let's initialize from constructor. Okay, so now we use, instead of food, we say tag to look for, and if it finds the tag, what does it do? Okay, so it now has found food or whatever we wanted it to look for. Now we want it to move to that location where it has found that object. Okay, so what we're going to do is, now we need a reference to the Cuboi's nav mesh agent. Okay, and now what we are about to do is provide our search for cartridge a reference to the nav agent, which does not make sense. Why? Because it's outside its responsibilities. It says search for, but it technically doesn't, it shouldn't actually move our object to let's say move our object to that position, but as I previously said, we're gonna do it anyways. So what we can do is we either provide a reference or get component, but get component is costly in terms of performance, so we're gonna provide it a reference to the nav mesh. So nav mesh agent is equal to nav mesh agent, and we ask for it, initialize field from constructor. Okay, and then we say nav mesh agent dot set destination wherever you found that object to be. Hit objects I currently iterating object, and we say transform dot position. Okay, so we just told it to move to the object which it has the tag you are looking for, and then break. Okay, so basically I'm breaking here because I don't want to look anymore if I have found an object. So let's test it, I suppose. Yeah, but we need to make certain things in the Cuboi. First of all, the Cuboi needs a layer mask, which tells it food items layer. Okay, so it needs to know which layer has food items in it so that it can search for it. Then let's say it needs to have view range item property field, sorry, view range. So basically it's our way of saying how far the Cuboi can actually find items. Okay, and both these things need to be serialized field because they're private, but I want to set them in Unity. Oh, sorry, search field. Okay, so we have view range, we have food items layer, and now we need Control Shift M, we need start. So as the start of our Cuboi happens, we want it to tell the state machine dot change state and provide it with new search for cartridge. Okay, so in that cartridge we need, first of all, provide a search layer. We need it, we know it's food items layer, so it's our way of saying search for food. Then we need to provide it with the reference to itself, and then we need to provide it search radius, which is our view range. Then we need to provide it tag to look for. Okay, so let's take this information outside as well, string food items tag, and let's say serialize field. So we all can provide food items tag, comma, is there any other information it needs? Yes, it needs a nav mesh agent as well. So our Cuboi must require component type of nav mesh agent. It's our way of saying, hey QBoy, if whenever we use the QBoy script on something, the nav mesh agent script should also be present on it. And if we drag our script onto something, it will all automatically add in a nav mesh agent for us as well. So we say comma, and in fact we should have a reference to our nav mesh agent, this, and as soon as we start we say nav mesh agent is equal to get component. Okay, I used the wrong one. Nav mesh agent. Okay, so I did it this way, so only one get component call gets made, and then nav mesh agent is passed. Okay, so this was a complete cartridge being provided to the state machine. Okay, you could save a reference to all this information and do a shortcut for this as well. So our state machine now is running as soon as the code boy gets running this state. Okay, but the machine has a cartridge plugged in, but the machine isn't using that cartridge yet. We need to use our cartridge in the update method. As I told you, the machine, let me quickly go back to the image, provides a way to execute what's in them. Okay, provides a way, doesn't automatically execute them. So in update method we say state machine dot execute state update. That's it. So whenever a frame happens, our QBoy's state machine uses whatever cartridge is currently plugged in. Let's go and test our script. Control S, and let's say QBoy. Now food items layer is food items, view range, let's say 50, food items tag is FOOD. Control S, our QBoy has been configured properly. Now it will create proper cartridges, and there we go. Our QBoy is continuously looking for food items, and it automatically goes there as well. Okay, now one other thing we could do is, for example, this QBoy is, as soon as it gets born, starts looking for food. Okay, so how would it know when to change state? For example, if it's looking for food and it wants to let's say after eating it, or now when it has reached it, it wants to eat it, or for example another enemy comes, okay, and we want the QBoy to look for enemies as well as look for food at the same time. Okay, so what we could do is, which I won't do in this video, but you could do is create a state machine which can run multiple cartridges at the same time. You could also do is have multiple state machines running at the same time. For example, one state machine is a let's say survival state machine, which looks for food and looks for looks for food, let's suppose. Okay, and another state machine which is a combat state machine which looks for enemies. Okay, this is for this part. In the next part I will teach you how to get information out from the execute phase of a running cartridge. For example, if the search for cartridge found something, it should be able to return it to you, so that you can do whatever you wanted to do once that was returned. For example, one possible scenario would be, if you have found it, then you should move to it, or depending on if it's an enemy, shoot it, etc., etc. So we'll do that in the next video.